Hey algebra students, in this video we're going to talk about graphing square root functions. This is going to be part one of the video, the most basic square root functions. So square root function just means that there is a radical or square root within the function. This is the most common, most basic square root function called the parent square root function, y equals square root of x. Just like with other functions throughout algebra, we're going to graph this using a table of values, at least to start. So we're going to create a table of values. We're going to substitute values of x into the equation to find y values. Because the square root of a negative is undefined, we're going to use values of x that make it non-negative. And the list of x values is going to help us identify the domain of the function. So we're going to figure out what values to put in for x. We'll choose wisely the values that we put in for x since we are taking the square root of them. So we'll choose that wisely, and we'll talk about that as we go through examples. But after we create our table, just like we've always done, we're going to plot the points. We're going to notice that it's kind of a curve, so we're going to draw a smooth curve through the points. And then the list of y values, either in our table or looking at our graph, is going to help us identify the range of the function. Down the road, we're also going to compare these to that parent square root function. So let's look at one. We're going to graph the function y equals 3 times the square root of x. We're going to identify its domain and range, and then we'll talk about comparing with the graph of y equals square root of x. So y equals 3 times the square root of x. We're going to pick x values first. This cannot be negative. So that means x has to be 0 or above. So we are for sure going to pick 0. That's the smallest it can possibly be. Now let's choose wisely. Since we're taking the square root of x, let's choose perfect squares so that we get whole numbers when we take the square root of it. So square root of 0 is 0. The next perfect square would be 1. After that, we're going to choose 4. And then the next perfect square for that would be 9. And then 16. So let's plug these in. 3 times the square root of 0. Square root of 0 is 0. Times 3 is 0. 3 times the square root of 1. Square root of 1 is 1. Times 3 is 3. 3 times square root of 4. Square root of 4 is 2. Times 3 is 6. 3 times the square root of 9. Square root of 9 is 3. 3 times 3 is 9. 3 times square root of 16. Square root of 16 is 4. Times 3 is 12. So here's our points: 0, 0, 1, 3, 4, 6, 9, 9. And then 16, 12 is off my graph, so I'm not going to worry about those. So there's my points, and then I just do the best that I can. Draw a curve through that and show that it keeps going. There's the graph. The domain, if you look at the x values, 0 we said was the smallest, so the domain has to be x is greater than or equal to 0. And if we look at the range, that's our y values. You can either look at the graph, where all the y values are, the smallest, and where the rest of them are. You can look at the table. Again, the smallest is 0, and then it goes above 0. So the range would be y is greater than or equal to 0. We'll talk about the comparison in a couple minutes. Let's do another example. This time we're going to graph y equals negative 0.5 times the square root of x and identify domain and range. So again, let's choose our x values wisely here. This can't be negative. It can be 0, but it can't be below that. So we can use 0. And then again, let's choose perfect squares. 1, 4, 9. Let's choose 16, even though it's going to be off the graph. And let's plug them in. Negative 0.5 times square root of 0. Square root of 0 is 0 times negative 0.5 is 0. negative 0.5 times the square root of 1. Square root of 1 is 1 times negative 0.5 is negative 1/2. Negative 1/2 times square root of 4. Square root of 4 is 2. Negative 1/2 times 2 is negative 1. Substitute square root of 9. Square root of 9 is 3 times negative 1/2, negative 1.5. Square root of 16 is 4. Negative 1/2 times square root of 4 is negative 2. Plot them. Negative 0.5. 4, it's at negative 1. At 9, it's at negative 1.5. As you can see, here's it's kind of curving this way. So I'll draw a smooth curve through it. I kind of missed that last point. That's all right. And then you can tell domain and range again, either looking at the graph or looking at the set of values in the table. Domain is the x values. The smallest was 0, so it's got to be greater than or equal to 0. For the y values, if you notice, they're less than 0. It's below the x-axis over here. So the range here would be y is less than or equal to 0. And that brings us to comparing these things. So much like we've done with quadratics, exponentials, we're looking to see what's the difference between our function and the parent function. So if you look back at ours, the only difference here is the negative 1/2 here. The only difference in this one is this 3. So those are the variable a. When the absolute value of a is bigger than 1, it's a vertical stretch. When it's less than 1, between 0 and 1, it's a vertical shrink. And we know that when a is less than 0, it's a reflection. So let's go back here. A is bigger than 1 right here. So this means this is a vertical stretch by a factor of 3. And the second one, we have a negative, so we know that that negative reflects it across the x-axis. And then a is actually 1/2, which is between 0 and 1, so this is a vertical shrink by factor of 1/2, 0.5. And it is a reflection across the x-axis. Got one more for you here in part 1. This kind of summarizes the comparisons a little bit. Let's graph one more. Y equals square root of x plus 2. We'll identify its domain and range, and we'll see what happens, how it compares to y equals square root of x. Notice that the plus 2 is outside of the square root symbol. It's outside of the radical here. So we're going to take the square root first, then we're going to add 2. So again, this can't be negative. It can be 0. And then let's choose perfect squares. 1, 4, 9, 16. And let's plug them in. Square root of 0 plus 2. That's 0 plus 2 is 2. Square root of 1, that's 1. Plus 2 is 3. Square root of 4 is 2. Plus 2 is 4. Square root of 9 is 3. Plus 2 is 5. Square root of 16 is 4. Plus 2 is 6. And let's plot them. So 0, 2, 1, 3, 4, 4, 9, 5, and that's all we're going to be able to fit. There's our points. Draw our curve through there, and there's our graph. Here's the domain. X is greater than or equal to 0. The range, this time the smallest number in the range is 2. And then they get bigger than that. So the range is y is greater than or equal to 2. Now when we compare it, The only difference is this plus 2 at the end. And if you can see, all it did was it shifted it upward 2 units. It's called a translation. 2 units up because it was plus 2. If it was minus 2, it'd be 2 units down. And those are some basic square root functions and how to graph some basic square root functions. We'll talk about some other square root functions in part 2 of graphing square root functions. I hope this helps at least set the foundation for graphing square root functions for you. Have a great day.